Welcome to qnawire.
Our question says that we have two balls made of wet putty that move directly towards each other along a vertical axis. And just before the collision, the mass of one of the balls, m sub 1, is 3 kilograms, is moving upward at 20 meters per second, which is, I call V1 for the velocity of that ball. And the other ball has mass 2 kilograms, m2, is moving downwards at 12 meters per second. So I say that's in the negative direction. So V2 is minus 12 meters per second. And it wants us to figure out how far the combined two balls of putty rise for this collision, neglecting air drag. So it's an inelastic collision. These putty balls stick together. We can do this, but first we need to find the final velocity of the putty based upon the initial velocities and masses of the putty. And then we can do that using conservation of momentum. And then we can use conservation of energy and consider the putty after the collision in free fall, and then calculate the maximum height from that. So from conservation of energy, we know that the final momentum is equal to, well, let's rewrite that, is equal to the initial momentum, right? Where the final momentum is equal to the final mass, m sub f, plus, or multiplied by the final velocity, v sub f, and the initial momentum is m1 v1 plus m2 v2. Okay, well, the final mass has to be equal to, since it's completely inelastic, the combined mass of the two balls of putty before the collision. So it's m1 plus m2, which is equal to 5 kilograms. Okay, so now if we solve for the final velocity, we have m1 v1 plus m2 v2. Remember, v2 is negative, divided by mf. Okay, so if you plug all those values into this expression, this comes out to be 7.2 meters per second. Okay, well, this final velocity of the ball is going to be the initial velocity for our free fall for conservation of energy. So from conservation of energy, the initial potential energy plus the initial kinetic energy is equal to the final potential energy plus the final kinetic energy. Okay. Well, the initial potential is 0. The final kinetic, also 0. Okay, so we can plug in the value, or substitute the initial, or the initial kinetic energy is 1/2 the mass of the final mass. We call that m sub f, which is the total mass of the two putty balls combined, multiplied by the final velocity squared that we just calculated, which is equal to the potential energy, which is the mass times gravity times height, or y max. Okay, and it's y max. The kinetic energy, we knew that k sub f is 0 at y max, right? So if it wasn't at y max, there could be a final kinetic energy if the ball is in motion, but at the peak height, that the ball is not in motion, so that is 0. Okay, so we can solve this then for y max. The masses cancel, and we find that y max is equal to 1/2 v of f squared divided by gravity. So plug in those values into this expression, and this comes out to be 2.6 meters. And box that in as our solution.